Muted.
Good morning, good afternoon, everybody. Welcome to our webinar today. My name is Ian Gillett from IGR, and I want to welcome you today to what is going to be a quite packed webinar on the smart connected building transformation. Basically, we're going to be talking about smart buildings today. And we've got a couple of presenters today who I'm going to introduce in 1 minute, Bill Kuhn and Jim Carlini. But firstly, I need to thank Corning for sponsoring today's session, and also for Connected Real Estate Magazine for putting everything together with us today. A couple of housekeeping items before we get started. Firstly, we are recording today's session. The recording will be available in about 24 hours or so. We have to convert the file and upload it. You will receive an email with the details of how to download the recording. Also, we will be making the slides available from today's presentation. Those will go out after the session this afternoon. The webcast is being streamed through your computer. There's also a dial-in number. For the best audio quality, make sure you turn up the volume. You'd be surprised how many people have the volume turned down on their PC or Mac. We will be taking questions today. If you could use the questions tab on the GoToWebinar control panel there, then we will try and address the questions as we go through today. And we will also have some time at the end for them as well. Okay, so what we're going to talk about today, there we go. So a couple of basically what we've done is break up the discussion today into 3 distinct topic areas. Firstly, we're going to talk about the evolution of smart buildings. Secondly, we're going to start talking about the smart building infrastructure. So firstly, we'll talk about what is a smart building, how do we get to where we are today. Then we'll get into what infrastructure do you actually have in a smart building and what does it do. And then the final section is we'll get into some case studies and some examples of frankly, things to do, some good examples, and we've got some not so good examples as well. So we'll get into that. What we're going to do is break it up. After each topic, we'll stop and take some questions and before we move on. So we'll try and keep things lively and keep things moving as we go through. And again, we will have time at the end for additional questions as needed. So in terms of speakers, as I said, my name is Ian Gillett from IGR, based down here in Austin, Texas. We also have Bill Kuhn on the call as well, as Vice President of Market Development at Corning, and James Carlini from Carlini and Associates, also on the call as well. So what I'm going to do now, I'm just going to literally ask Bill and Jim to introduce themselves for 30 or 40 seconds and give us a quick synopsis of what you do in everyday life and how you're involved in smart buildings. So Bill, if you want to go first.
Sure. As Ian mentioned, I'm the VP of Market Development at Corning in our wireless and in-building networks organization. And my group generally spends our time working with the market to identify trends, understand where things are going, to identify the opportunities to create new and differentiated solutions that solve customer problems. The other half of the time, we're evangelizing those solutions to the marketplace, but we're really the tip of the spear of what are the trends that are coming and what do we need to do to make sure that we enable that. And then smart buildings, why we care about smart buildings is that at the end of the day, you guys know Corning as a connectivity company, a fiber optics company, and none of these systems will work without connectivity, and certainly smart buildings need to be enabled by that connectivity. But we have to think about the applications that the owners, tenants, et cetera, are looking for, and so we care very much about smart buildings, and because it drives the overall network design.
Okay, great. And Bill, where are you based?
I am based in Charlotte, North Carolina.
Okay, great. And Jim, 30 seconds, what do you do and why do you care about smart buildings?
Well, I started back in 1985 with Intelligent Buildings when I was a director at Arthur Young. Now it's Ernst & Young. And I've worked with different intelligent buildings and mission critical architecture for the last 30 plus years. I include the being the chairman of the definitions committee for the Intelligent Buildings Institute in Washington, D.C. back through 1986 to 1988. I wrote some white papers. I wrote a chapter in Johnson Controls Intelligent Building Source Book back in 1988 that talked about measuring a building's IQ. And I worked on a lot of mission critical applications. I was a mayor's consultant on the 911 center in the city of Chicago, where we used a large amount of fiber optics, and worked with the Chicago Mercantile Exchange and other companies in putting in not only intelligent infrastructure, but intelligent amenities. And I've written a book called Location Connectivity that talks about all these projects and how things have changed as far as within the real estate area. And we'll talk about that during the presentation today. And I've also taught at Northwestern University for 20 years as an adjunct professor in both the undergraduate and the executive master's program, talking about technology management, network security, and other issues involving mission critical infrastructure.
Okay, and given some of the place names you mentioned, I'm going to guess you're based in the Midwest somewhere. Is that right?
I'm outside of Chicago and always been in the Chicago area.
Okay, great. Okay, so let's get into the content now, and let's kick off the first subject, and let's talk about the evolution of smart buildings. Yeah, and we'll talk about what is a smart building, how do we get to where we are today. I'm actually going to kick this one off firstly, and this is some stats I put together from one of our reports, from our research. It's actually taken from the U.S. Census, I think it is, or one of the U.S. government databases. But this is commercial buildings, U.S. commercial buildings by size for 2017. And you can see the pie chart there on the left-hand side. This is actually by square footage. So 49%, nearly half of the buildings, commercial buildings in the US are actually under 5,000 square feet. And you can see a very small percentage, actually just over 1%, are actually over 200,000 square feet. I think a lot of people imagine that a commercial building is that huge commercial tower block, that a big shopping mall, etc. But the reality is that most of the buildings are actually quite small. And if you add up the numbers here, you can see that basically what over 85% actually are under 25,000 square feet. Now, in terms of the statistics of how big the market is here, there's actually a total of 5.7 million commercial buildings in the US, and that's the number I like, 97 billion square feet in total floor space for those commercial buildings. The majority, of course, are very small, as we said. About 144,000 have more than 100,000 square feet of covering. So even though the large building is a small percentage, that's still 144,000 buildings is obviously a large number. And the wireless, indoor wireless systems today cover about 2.84 billion square feet. Let's call it 3 billion. Keep the numbers whole here. So you can see it's about 3% or so of the total available market. So it is relatively small in terms of how much we're actually addressing. So think of this as the total addressable market. Obviously, there's a lot of buildings out there, a lot of space, and obviously, with wireless being a relatively small part, not all of them are smart by any means. So Jim, I'm going to pass to you for the next couple of slides here. I want to talk about how do we get to where we are today? What is a smart building? How has it evolved? And how have we ended up where we are in the 21st century?
Well, number one, I think we have to get on the same page. About a decade ago, there was a big study on infrastructure, and infrastructure is tied in with buildings as well. And when we talk about infrastructure, we have to take a look at all the different layers of infrastructure. And what I found out back then was that the Association for Society of Civil Engineers had a report card that a lot of people might have remembered, where they rated all the different layers of infrastructure, B minus, maybe C plus for the highways, C minus for the railroads, but they left out network infrastructure. And one of the things I saw was that before we get moving on developing and improving on things, we all have to get on the same page. And I put together this platform for commerce, a sort of a framework of all the layers of infrastructure. And it better defined all the different things that we have to take a look at, because this platform for commerce is what we're building these buildings on. And if we don't have everybody on the same page when we take a look at trying to do improvements, what we do is we find that a lot of people are not working together. And we'll talk about that in one of the later slides, where a lot of these things have now become convergent. And when we look at real estate, we're not only looking at real estate, but we're also looking at infrastructure, technology, and regional economic development. And I think you'll see that as we talk more today, that we have to understand everything that's going on. And we also have to take a look at this as being an investment and not an expense when it comes to adding these intelligent amenities like redundant power, redundant broadband connectivity. These are things that improve the marketability of real estate. And when you take a look at that, you have to make sure that you're not looking at it as a cost of doing business. You're looking at adding all these capabilities as an investment to get a higher caliber of tenant.
Okay.
Go ahead.
Yep.
The other thing is that we can't solve 21st century challenges with 20th century solutions. A lot of times when you look at different courses that you take at universities, they're trying to sell you the same stuff they sold you 20 years ago, and that just doesn't work, especially in this area. We've got so many different things to focus on, and what might have been a best practice 3 years ago is now obsolete. And I think we should get off this idea of best practices and talk more about leading practices, because then we're more on top of these things, because it's always continually changing. And so we have to get rid of this idea that what you learned 10 or 20 years ago is still applicable to some of today's challenges. And that's one of the big reasons I wrote that book, Location Connectivity, is to talk about these things and how they've shifted in real estate. And today we're going to cover a lot of that today between myself and Bill and Ian.
Great, thank you. So Bill, I want to hand off to you now and start with this slide. And I really want to talk about how you view smart connectivity. In your introduction, you said, that Corning, obviously we know you as the fiber company, and connectivity is part of a smart building infrastructure. So maybe talk a little bit about how you see the connectivity. We've got a lot of green and red on this chart and a lot of pretty pictures. So maybe talk about how you view the market here, leading on from Jim's comments about, we can't do what we did 20 years ago.
Right. Yeah, so happy to do that, and I'm pleased to talk to these pretty pictures. Fundamentally, we talk about smart buildings, and the way we look at it is you can't just think about the smart buildings without thinking about the context of the overall smart city and the smart homes and the complete environment, because you can look at a smart building, and if you only look at it from the perspective of the building owner and trying to make your building more efficient, then that's fine. It's a closed system. But the world we live in isn't a closed system. It is a system where mostly what we're trying to do is provide services to people, and those people are mobile from their homes to their businesses, to the places of entertainment. So everywhere we live, work, and play has to be covered, and we'd like a seamless experience. And wireless right now, we want a seamless experience for voice and data. We want to, and we'd like actually for that smart experience to also be seamless, so that when you're leaving your home and you type in the address on Waze, that it knows that you're going to your office, it knows what your time of arrival is, and perhaps it knows when to turn on the lights and turn up the thermostat in your office and perhaps get the coffee maker going. Whatever it does, maybe even tells you where a free parking space is. So it's that kind of thing that we need to think about, this connectivity from the core all the way out to the edge. And this is, of course, where Corning spends a lot of time. The green is where fiber has, been laid for, you first had, long haul, then metro area coverage, and then, going to the buildings and going to cell towers. But, what we find is that, fiber just keeps getting pushed deeper and deeper into these networks because it's at the edge of these networks where we spend most of our time. And, whether we're in our homes or in our offices or at a stadium, and then anywhere in between is where we will deploy both the wired and wireless connectivity that's necessary to enable this smart experience.
Okay, great. So we do have a couple of questions before we move on here, and I think it's probably a good time to address a couple of them, actually, and I think they relate to that first chart I showed. So the first one is, it's more of a statement, actually. Only 3% covered by wireless. Somebody was kind of surprised at that. And I should clarify, and we will get into this a little bit later, but that's covered by a cellular system, so LTE, 3G, etc. Obviously, a lot more buildings have Wi-Fi, which I know we're going to talk about later on. And I think, Bill, you've got a slide later on talking about the evolution of Wi-Fi and how it plays into that smart building. So obviously, if you go into a large commercial building today, it's unusual not to have any Wi-Fi. Whether you can get access to it or not is a different question, if you're a guest or a tenant or whatever. The other question we had was of the 2.8 billion square feet that are covered, how do they break out between small, medium, and large type buildings? And the answer is the majority of them are large. And I think, Bill, you've seen this pretty well over the last, and Jim as well, that the carriers, certainly when they were building or funding DAS deployments, they were going after the entertainment venues, the large stadiums, the football stadiums, NFL, et cetera, et cetera. And so you do get those large type buildings. You don't usually see a cellular system in an office building of, let's say, 25,000 square feet or something. So I think, Bill, you've been involved
Correct.
in that for some time, right?
Yeah, we have been doing that for many years, and for the most part, it is the larger buildings. You occasionally find a customer that wants to cover 3-story or 3 floors in a 50-story building, but that's few and far between. It's usually where the wireless carriers can justify the expense to deliver just cellular service, and that requires either public space or an identifiable customer that they can sign a contract with. And so that makes MDUs difficult. It makes small buildings difficult. But there are technologies and solutions that are bringing cellular down from that 500,000 square feet and up on down into that middle segment down to 100,000 square feet and even below.
Right.
One thing I'll point out as well that, and I think it maybe on this slide it kind of draws it out as well, is that many of the environments, we shouldn't really be thinking about them as individual buildings, but collections of buildings. And if you do a campus for a university, you may have 3 big buildings and 30 small buildings, and those 30 small buildings would never justify putting in some sort of service on their own. But in the context of a 2 million square foot campus, for example, you're able to cover them all. The price per square foot is the same. So in the context of that, it makes a lot of sense. And I think if you think about cities in that way as well, that you want this smart experience everywhere. And I think these solutions are becoming more and more scalable, becoming more and more deployable by the end user, by the enterprise, by the building owner, et cetera. So I think that there's an opportunity here.
Yeah, great. Yeah,
let me add to that. Number one, when you talk about NFL stadiums and some of the professional sports stadiums, what I found is that because there wasn't a lot of rules of thumb, most of the design engineers came in and they designed it for coverage, and they were there the next year to come back and add a lot more antenna, because then they saw that you couldn't address all the people using their smartphones at once. So they had to come back and add a lot more antenna the next year, because then they were looking at capacity. And I think that's something that from a rule of thumb, from a design standpoint, you have to look beyond coverage. It's like, yeah, I can cover this area in a stadium, but the bottom line is if I've got 30 or 40 or 50,000 people all of a sudden cranking on their smartphones, I've got to have a lot more capability and capacity than what the initial design specs had. So I think that there's still a lot of learning curve, not only with professional sports stadiums, but even buildings, because what's good enough for one building A may not be enough capacity for building B. So we have to make sure that we don't look at things as a one-size-fits-all solution. And that, that just doesn't go for this area, but it goes for a lot of technology that's been implemented in the past. A lot of times people look at things and say, well, if it worked at building A, it should work in building B, only to find out that they needed a lot more capabilities. So that's one thing that I sort of caution on. And then the other thing is that when we talk about intelligent business campuses, where we have multiple buildings, I've worked on things where you have a technology park, an 800-acre park, and we were bringing in several different network carriers at 40 gigabits per second. And I want to emphasize that because a lot of people think that, oh, if we're bringing in something with 1 gigabit or whatever, we're more or less set for life. It's like if you want to be competitive in the global marketplace today, if you have an industrial park, you're looking at least 10 gigabit per second today. If it's a business park where you have Class A type corporate tenants, you should be looking at anywhere from 40 to 100 gigabit per second services coming in from multiple carriers, not just one. And just to give that as a perspective, because I saw an RFP come out from one city, I won't mention which city, but they said they wanted to develop this one like high-tech business area, and they were looking at 1 gigabit per second as the speed that they wanted to have coming to the buildings. And it's like, that's already obsolete. So right. If you're looking at the planning, if you're looking at planning at this point today, you should be looking at this, and you should be looking at multiple gigabit speeds coming into a building. And if you're looking at a campus, you're looking at multiple buildings, you should be looking at 100 gigabit, and it should be multiple carriers, not just one.
Right. Yeah, that's a good point. And actually, it probably leads on to this the next slide here from Bill. If talking about the network here, obviously we've got a lot of the smart core, and then you've got the applications and services on the side there. The network here becomes key. And to Jim's point, the carriers, after every major sporting event, they always put out statistics about how much is used, right? How many terabytes the audience consumes sending photos, etc. Right?
Mm-hmm. Right. Yeah. And Jim did those some great points, because you have to think about any building and the life cycle of the building and how it's going to change. And if you build a 50-year or 100-year building, you know that a lot is going to change over that time, especially with technology. And so you ought to plumb your building. You ought to build out the network in your building such that you've got maximum, future flexible infrastructure in place. And, because, as Jim mentioned, you design a building for one sector 1 year, and 2 years later you're in there designing it for 5 sectors, then it's 20, and then it's 100. You don't want to have to go in and rip and replace everything every time. So the other thing about the smart building as well is that, people often build single purpose infrastructure. And so they'll build a LAN system for their security and surveillance. That vendor will propose an entire LAN network, and for building automation, and for access control, and for the tenants, and so a lot of parallel networks going in, a lot of different trades quoting similar things and building similar things. And yes, you look at these buildings, fiber has been the great converging media. It's 100% of campus connectivity, and it's about 80% of riser connectivity inside of buildings. But it is a convergence media, and it goes out to an aggregator, and you build that, and you can support your voice, analog and digital voice services. You can support all your video. You can support cellular, etc. But if you design your network up front so that it supports your LAN, your Wi-Fi, your cellular, any of your specialty networks to enable these endpoints, both from your tenants and guests and mobility, as well as all that you need for security and managing the building, plus video, etc. You need to think about all of that. If you really want a smart building, you need a smart network and smart infrastructure. And there's a smart way to design that, a smart way to lay it out that actually spends less money on all of the cabling and electronics, and more money is allowed for the toys out the end, the things that you really care about.
Right.
Let me interject something on that. Is that you have to look at the true cost of cabling. The true total cost of cabling is not just the initial setup and the initial design. It's whether or not you have to go in, as Bill pointed out, 5 years later, disrupt everything you've already built, and then rebuild it and redesign it. We got away from the rule of thumb that says when you build a network infrastructure, it should fit the lifespan of the building, not the lifespan of the technology that's hanging off of it. In other words, I switch out desktop computers every 3 to 5 years. I shouldn't be switching out the network infrastructure or the cabling infrastructure that's connecting them. And I see that over and over and over again at a lot of these corporations where people do not have a long-term vision. It's like, well, let's just fit the cable for what we've got today. And 5 years later, they're tearing down the walls and putting in the next flavor of cabling.
Right.
That stuff has to stop. You put in cabling, let the cabling go in there for 30, 40, 50 years. And the true cost of cabling, even if that stuff costs you more money up front, during the long term, you're going to save a ton of money, not just only in the components of the network infrastructure, but all the disruption to all your people, because you're bringing in all this labor to redo the network configuration that you just put in 5 years ago. And a lot of people don't add those types of costs when they start to plan these things out. And that's mentioned in my book, just to give you a cue.
Yeah, so what you're saying, Jim, is just because you change a light bulb doesn't mean you rip out all the electrical wiring, right? The electrical wiring is there for the life of the building. So let's talk about what this infrastructure is. We've talked about, we kind of got into it in the last section here, and I do want to keep moving on because we've got some more content to get to here. But Jim, I want to talk about, you've got a couple of slides here talking about what our infrastructure needs to do, and you've cut on the different points. But Bill made the point that, hey, we've got a lot of things to support here. We don't want a single-use network, and I think you've got some of the things here you're talking about that we've got to support. So what does a smart building actually support?
It all depends on who's your tenants, and that's a big thing. Here again, it's not a one-size-fits-all. Depending on who your tenants are, look at all the stuff that's up there, and nobody can tell me that they're an expert at every buzzword and everything that's up there. And what we have to do is we have to take a look at being more of a, put it this way, there's no experts in this industry. The best you can be is a good student, always learning. I used to tell that to all my students at Northwestern and they walked away with a lot different perspective than thinking, oh, I'm an expert at this or I'm an expert at that. When you throw up 20 or 30 different types of technologies that are going out in their own direction and more or less setting up their own industries, you can't be an expert at all of it. But what you have to do is you have to understand that there are interrelationships between all these things, and how do you put up the best network that's going to support the ones that you're focused on, whether it's a multi-tenant building, whether you're the corporate tenant within the building. But you have to see what are you trying to address and then design your network to accommodate that. Go ahead.
Okay.
Again, just for one idea, when the real estate, this was the basic concept of the book, is that before we dealt with 4 different areas, and the way we educate people is through a silo-based degree where you have a degree based on technology or real estate or infrastructure. But now what's happening, and this is the actual marketplace, those 4 areas have converged. So now we have real estate, technology, economic development, and infrastructure. And if you want to sell to that marketplace, you have to understand that it's a convergent marketplace. Or if you're building something, you have to realize that all these things are sort of meshed together. And so you have to have an understanding of all those four areas rather than saying, well, I'm a technology person or I'm a real estate person. Those people don't get it because they don't see how all these things have interrelated. The sharpest people that are out there today are the ones that understand that this convergence has taken place over the last 3 decades. We're not talking about today. We're talking about over the last 3 decades. And that's why when you take a look at these programs at some of these universities, and they don't have one course in their real estate department that talks about intelligent buildings, that's not a new concept. That's been around since '85. And yet they haven't kept up. They haven't kept up with what's going on. And that's the reason everybody's starving for education, and we're just not educating people in where the market is today. The market is where you see on the right-hand side. That's the market of today, not the stuff on the left side where they're separated spheres.
Right. Go ahead. And I think this slide I like particularly. We're going to get into this more in a second here, but you talk about the 3 R's, right, of what you need.
The 3 R's. It's not reading, writing, and arithmetic. When it comes to mission critical, applications, it's reliability, redundancy, and resiliency. And I'll make you a bet when it comes to that, I can throw out a number like 96% of the buildings out there you can't have any type of corporation living in that building because the building itself doesn't support mission critical applications. How many buildings out there, downtown office buildings, where you see where they're connected to 2 central offices or 2 separate power substations? There aren't. It's the horse and buggy approach to architecture where you have a single connection to the central office and a single connection to the power system. And by that virtue alone, you cannot support mission critical networks and mission critical applications because they require no single point of failure. In other words, you have to have dual power, dual communications, and you don't have that today. And right now, corporate applications, 1 out of every 3 are considered mission critical, and that number is growing to 1 out of every 2 mission critical applications. So there's a lot of work to be done out there, which in a way is good for people because there's a lot of work for people to work on.
Yeah, and I know you've got a really good example of this, which I want to hold until the end because I think it's a good discussion point. So Bill, I want to come back to you now. We're talking about infrastructure, the smart buildings. We need the 3 R's. We've got to build this stuff out. There's a lot of work to do. And then I'm going to shift it a little bit here because people are also hearing 5G. We've actually got quite a few questions coming in, which we will address in a couple of seconds here. But I want you to walk through here the components here of 5G, how it fits into smart building infrastructure, and your kind of views on that.
Absolutely, and I'll talk a few slides here about 5G, and really I'll try to hone in on the impact of why is 5G different, and what does that mean for how do you build out infrastructure in a smart building or a smart city. So most of us, who've lived through this, back in 1985, before there was cellular, I was designing cruise missile guidance systems, and so I've kind of changed my industry a little bit. But think about the 1G transition to 2G and to 3G and to 4G. They were really all about, first going from voice and then getting digital voice and a little bit of data and then more data and more data and more bandwidth. It was all about increasing the speed that you get to a single device, and that device being able to consume a lot of bandwidth, and finally up to video. And so, yes, 5G is about that. 5G is about being able to support 8K, Ultra HD video and virtual reality and augmented reality. But it's about much more than that as well. It's also about very low latency, which had not been a big issue with cellular networks, because we want real time applications to run over this network for someone to be able to do surgery or to ride in autonomous cars. And And then the other aspect of it is that, as you optimize these networks for, each of us to be carrying one or two devices and consuming a lot of data, that was kind of the other end of the spectrum, is a whole bunch of devices, billions and billions of devices consuming a very little bit of data, but many, many connections that are, important. And that's the Internet of Things. And so 5G is actually trying to address more with this next generation than what you typically saw the other generational shifts. And that has some implications on the network. Let's go to the next slide. So one of the things you think about is, 5G does need, it needs a lot more spectrum. And so 5G will have millimeter wave in use, and that's the only place where there are hundreds of megahertz worth of spectrum available to create this really broadband experience. But it will also be deployed down at the mid bands, and there'll be carrier aggregation. But what that does is make your networks more complicated, and which is fine. If you're going to try to aggregate multiple bands, you need a system and a network in the building that can do that. But the other thing about getting more out of this, you have more spectrum. You also want more spectrum efficiency, and it's a little bit technical, but this MIMO technique and massive MIMO is something that the point to make here really is that you can't do massive MIMO over a coaxial cable network. You need to have active electronics out at the edge. You think about your Wi-Fi 802.11n or AC that has MIMO. It is an active element out at the edge with embedded antennas. At millimeter wave frequencies, it could be an 8x8 antenna array, or even bigger than that. And so the point here is really that 5G, with these techniques that are required to get this kind of bandwidth, will require an active element out at the edge. The other thing to think about as you think about these buildings is that it's a combination of licensed and unlicensed spectrum. It's also a combination of LTE and Wi-Fi working together, and other technologies. It's trying to build an environment where multiple technologies coexist or collaborate, and where perhaps the unlicensed bands are being used by LTE in a same environment where Wi-Fi is being used. So these are kind of things you need to think about, and the implications really are that you need a big fat pipe out to a active antenna element to really enable 5G inside the building. You want these things to be intelligent and software configurable, and so there's a lot that goes into designing these systems. So that's kind of out at the edge. If we go to the next slide, the other aspect about 5G that I want to point out is that right now today's cellular networks really are a cell. First, it was a cell that used a certain subset of frequencies, and then another cell, neighboring cell, that used different frequencies, and you had this frequency reuse pattern. Nowadays, it's the same spectrum, but there's techniques that make them coexist. However, neighboring cells and the phones act as interferers in the cell-based network. And as the closer you are to a cell, the better you are. And if you're out at the edge and seeing a couple others, you might be in a bad signal-to-noise ratio area, et cetera. So what's happening in the future of these networks, and in the not too distant future, is that not only are you active out at the edge, but the processing, the intelligence is getting centralized at a core, so that those radio nodes out there are actually able to collaborate and cooperate and coordinate, so that you as the user might be getting some of your data from one tower, and some of it from another tower, and some of it from a different tower, but it's optimizing the network so that interference is mitigated. So the real point here on the 5G is that 5G networks really are different. They really will need active electronics out at the edge of the network, which would be throughout your smart building, throughout your smart city, and perhaps throughout your smart home. But to get them to work properly in the architecture of the future, they will also need connectivity back to a centralized processing location. So next slide. So the other thing I just wanted to point out is that Wi-Fi obviously is part of this. The earlier question was about wireless being in a very small subset of buildings, and that was cellular. We know Wi-Fi is everywhere. It is pervasive. The interesting thing, though, is Wi-Fi. I make a distinction between Wi-Fi being a wireless technology, whereas cellular is a mobility technology, and there is a difference there. Wi-Fi is wonderful when you're untethered and sitting still. If you're nomadic, it becomes a little more problematic, and that's what LTE and mobility has been all about, is that nomadic behavior and be able to maintain a consistent experience throughout. So they're both important parts of this, this future, well, actually the current network and in the future network. And Wi-Fi continues to improve. And you look at this table, with the, we're at AC right now is what mostly people are deploying, maybe still a little bit of N, but AD is the 60 gigahertz solution that, both the AC and AD go up to multiple gigabit per second as your backhaul rate. And then you can get up to the AX, which is down at the lower bands, up to 10 gigabit per second, and AY up to 100 gigabit per second. So the point here really is that, Wi-Fi is continuing down this path. It is getting more and more capable from a throughput per a single access point, multiple MIMO streams, a very complex system out at the edge that requires a tremendous amount of backhaul. And so how you design your network to support that Wi-Fi, will you need a 10 gigabit per second at every Wi-Fi access point throughout a million square feet? Probably not. They won't all be doing that at the same time. But you do need a system that can support it. Yes, and so how you design your network, even just for Wi-Fi, so that you can be future flexible, is important.
Okay.
Maybe we can stop here on any questions.
Yeah, and I think we've got quite a few. I was looking, as you were talking there, Bill, I was looking at the questions panel, the question screen. We've got quite a few coming in. So let's get a few out the way right now. And I think the first one is, and there's a couple of questions relating to this, is the relationship between the building owner and the tenant. And we've talked about putting in 5G. You talked about putting in massive MIMO antennas, for example. We talked about all these different solutions. And the first question was, well, where's the breaking point between the tenant and the building owner? Who does what? And then obviously you could have, let's say, a law firm in the big commercial buildings put their own Wi-Fi in. If somebody else wants to put in a 5G system, private LTE network, let's say, is that the building tenant responsibility? Is the building owner responsibility? And I'll start with you, Bill. Who do you see from your experience leads that? Or is it the case of it depends?
Yeah, I mean, that's a great question. And unfortunately, the answer is it depends. Almost every case is different. Sometimes you have, a tenant who cares so much about something that, so I'll give an example. I mentioned it earlier, but we did 3 floors of a high rise in Manhattan years ago. It's probably a total of 60,000 square feet. And there's no way any wireless carrier was going to come in and provide a signal for that. The company paid hundreds of thousands of dollars for CDMA base stations because it was that important to them to have their customers working on have their devices working inside their space. So it is really it's a complex ecosystem. There's many stakeholders in this game, and what we think is the first and foremost that as you're plumbing your building, you ought to put in and insist on a single converged infrastructure for all of the things that you need as a building owner or as a developer, and build it out so that you can enable both tenants to do what they want to do and service providers, whether they're landline or wireless or anything else, to be able to come in. But what you don't want is somebody coming in and coming in and saying, hey, I need to install a new infrastructure for your building so I can serve my customers. And then somebody else comes in and wants to install another infrastructure to serve their customers. You should put one highway in and let everybody drive on that highway. And then the more roads you got covered with highway and the shorter the off roads, the side roads are, the better everyone is.
Right. So, Jim, you mentioned earlier some of your comments about the building and protecting the investment, et cetera, et cetera. We talked about the stadiums, the carriers building out those stadiums. And you said they're built for coverage, and they came back and put capacity in later on. from your perspective, what do you see as a relationship between the carriers here as we move into 5G and the smart building, let's say the building owner or the tenant? I mean, do you see a situation where a building owner builds out a network, then leases capacity back to the carrier, for example, because they built it?
Well, I'll give you a great example, and it covers the commercial buildings that Bill was talking about as well. Number one is, remember this, everything is market driven. If I'm in a market where I don't have to do anything but just rent out space, then I don't have to do anything to my building. Now, that market has been shrinking intensively in the last 20 to 30 years. Real estate people used to just think, okay, that guy over there is $18 a square foot. We'll drop it to $15 a square foot for our building. And then the next guy that's more hungry, he says, well, I'll drop my building to $12 a square foot. And you get all these people, all they're doing is selling space. Well, today you can't just sell space, and you have to take a look at these things that Bill was talking about and what I was talking about as intelligent amenities. Just like someone wouldn't move into a 30-story building unless it had an elevator. The traditional amenities like elevators and HVAC, people expect them to be in a building. Well, people are now starting to expect certain types of broadband connectivity within a building. And if it's not there, they move on. And so building owners and property management companies have to think about, what do we put in the building to make it enticing to a Class A corporate tenant? Now, if you don't want to address the Class A corporate tenants, then I guess you don't have to really think about these things. But if you want someone to be in your building or be in your intelligent business campus where you have multiple corporations within a 100 or a 300 or a 1,000 acre campus, you have to look at what should I be bringing in. One of the things is that when you say, should the building owner or the property owner do some of this, I say definitely. I worked with one business park owner where they were going to let AT&T come in and put in all the conduit. And at short glance, you say, hey, that's great. That's money that I don't have to worry about putting in. They're going to bring in their own conduit. The problem is, once the carrier owns the conduit, then they can more or less dictate who else comes in there. And it sort of strangleholds the property owner then as far as having other types of carriers come in. Whereas if they put in the conduit and then they more or less let the carriers come in to that conduit that's owned by the property owner, now all of a sudden they can offer 3, 4, 5 different carriers, and they're not hamstrung because one carrier owns the property, owns the conduit within the property. And so that's a big shift. Again, that's a big shift in the mindsets, or should be a big shift in what they look at and say, oh, do we let a carrier do this? Or do we put in our own conduit, and then that way we can bring in 2 carriers, 5 carriers, whatever. And that's something that, it's a planning decision. It's upfront when you do the planning, but it's a huge decision when you look at the lifespan of the building or the intelligent business park, intelligent business campus, if you're looking at building something for 30, 40, 50 years.
Yeah, and as you say, this is what people are expecting. My kids are getting out. One's out of college, one's getting out of college. They're used to having bandwidth wherever they want it, all the time, on demand, and they expect that in their apartment. They expect that in public transport, and of course they expect it when they go to the office and when they go to work. And as they rise through as their careers evolve, they'll be making more and more decisions about where companies are located. So Bill. Yeah,
that'll make a Class A building go down to a Class B building. If they're not offering the technology and the intelligent amenity, the corporate tenants, the Class A corporate tenants, will move on. They'll go to another building. They won't move into your building if you've got horse and buggy amenities.
Right. So, Bill, I want to shift back to you. We've got literally 8 minutes left. I know we've got quite a few slides here. I think we moved these fairly quickly, but I know you've got some case studies of different things we want to showcase here. So if you want to walk through this, then we'll open up at the end for some more questions.
Yeah, absolutely. So I'll walk through it quickly. I think before we get into the case study, just quickly, the Corning solution that will be highlighted in this case study is the Corning One solution in these case studies, where fundamentally, it is a fiber deep infrastructure, very simple network topology that future readies your network. And one thing about taking fiber deep into your network, if you put active electronics out in places where it's not a closet, you need to deliver power. And so that problem's been solved to deliver hundreds or thousands of watts of power over a composite cable out to the edge. So whatever you might need, a fiber power distribution solution is what we're really talking about, and getting out to these edge locations. And then Corning also has equipment and network solutions that enable both cellular and LAN. And so we have cellular DAS equipment. We also have small cell enterprise radio access network, small cell solutions, and combinations of those two to kind of provide an end-to-end solution that the carriers need. And then on the LAN, we have software-defined LAN solutions as well that have small, 2-port and 4-port units that are designed and optimized for out at the edge. And so these are all the things you need to enable wired and wireless connectivity inside of these smart buildings. So let's go ahead and jump into the first case study. And I'll try to go through these rather quickly, but I think the point of all of them is that the customers in a variety of different vertical markets decided to design and converge multiple networks onto a single fiber deep infrastructure, and they leveraged it to do many, many things, which, had they gone around and done this a different way with different parallel networks, it would have and could have cost a lot more money. So they saved money, and more of their money went towards the actual appliances and devices they needed to use. So here's a case. It's a Courtyard by Marriott, moderate size, 144 room hotel, but they did high speed internet and Wi-Fi and IPTV to the guest rooms, and then supported all of that plus their building management and their LAN and point of sale and security off of the network as well, in the back of house and all the public space. And you can see in the lower pictures that all these hotels have equipment behind the TV, but here's a case where fiber and power was brought to the room, and there's a Wi-Fi access point back there. There's the any gear you need for LAN, IPTV, etc., is kind of mounted there behind that device that's holding the TV. And so they're doing this because that fiber and power to the room gives them really a future-proof network with virtually unlimited bandwidth and significant power advantages over normal kind of category cable and PoE deployment. Right. So let's go on to the next slide.
Well, it's a shame you couldn't fix that wallpaper as well at the same time, but
yeah, I know. It's hideous, but yeah. So here's another case. It's a corporate headquarters building where this is supporting Wi-Fi, a multi-operator distributed antenna system, security and building management, as well as IPTV. And the picture over on the right, you can see it's just a typical, moderate size office building, but parking garage. The top right photo there is actually a photo of the multi-band cellular remote that also has, integrated gigabit Ethernet capabilities to plug in a nearby security camera, etc. The lower left picture you'll see is that the box on the right is actually the fiber to the edge ONT, and so there's several ports on that to plug in PoE devices. And so just a combination. The entire infrastructure is done with fiber to the edge, both for cellular as well as their LAN and all the applications. And then next. All right, corporate campus. And can you guys still hear me?
Yep.
Okay, great. Yeah, so corporate campus, this is a research building. It's just another one. What was exciting about this one was, again, this is fiber to almost every single device. Most of the devices have one application connected to that endpoint, and it's got Wi-Fi. It's voice over IP. They chose to go wireless first, so there are not a lot of ports and not a lot of hardwired connections in this building. But it also has multi-operator DAS, and they support their building management. and the security on it. What's interesting though is their digital signage solution that they chose actually had SFP fiber ports on it, and so for these they chose to go with fiber directly from the head end of the building out to these locations. So I think that's a key point that I need to make, is that in all of these architectures, every one of these fiber endpoints goes back fiber to one single concentration point at the building. So everything has a unique fiber path to that one point. There's no aggregation going on elsewhere. And so this is important when you think about the flexibility of your network and what you can do with it in the future. And so great example here of actually fiber to devices and that fiber plugging right into those devices. Next example. So this is one that, again, just showing the versatility of this. This is a campus that has single family homes as well as multi-dwelling units, the residential community. But, the solution's actually being used for a private fiber to the home network to deliver video and high-speed internet and Wi-Fi and POTS lines. So a lot of flexibility in this solution and the capabilities and how you can deploy it. And I thought this was a useful case to include because it's just one you don't typically think about when you're thinking about just doing a building. And then the next use case, large hospital. In this case, they already had plans for other things, but here's a case where they view the fiber and power to the edge as something useful for just the security cameras, and so that was the first application that they put in. But fiber and power deep to power their cameras and connect them, dramatically simplifying the architecture. Did not have to build out IDFs and put switches out at the edge and run 100 meters of category cable. These all go back to a central head end. And then now that they've put this out there, they realize they have that power and connectivity at the edge, and so now they're starting to add Wi-Fi and other applications off of these locations. So that's it for the kind of my case studies. I think that this one slide here is really kind of meant to drive it home. This is a large hotel that's connected to some public space in Chicago, but we did this with Marriott with an all fiber to the room convergence of all of their networks, including cellular DAS. And I think the lower left quote is really perfect. I mean, this is why people think about this, is that they're building a 100-year building. They want a 100-year infrastructure, and perhaps the fiber might actually outlast the buildings. And then the upper right quote is really drives it home. When you do this and you replace a whole bunch of relatively long copper runs with an aggregated fiber run deep, and then have short copper jumpers, they saved 750,000 feet of copper, and so tremendous savings, as well as creating a very future flexible network.
Yep.
So that's it for my case studies.
Great, thank you. So we're just about out of time, but we've got a couple of slides left. I know that some of people have probably got to drop off and run to other meetings. Just a couple of very quick housekeeping questions. There's a few questions in there. Firstly, any questions we didn't get to, I will get to Jim and Bill this afternoon, and we'll get back to you in email. Secondly, we will be sending out the slides after the event, so you've got all the case studies. I know there were some questions, Bill, on follow-up on these case studies with some specific detail, so I'll send those questions to you. Okay. And also, of course, we will be recording, and that will be available. Now, Jim, I want to come back to you finally and literally take just literally a minute. But you mentioned earlier on about your 3 R's, and I know we're going to talk about the bad examples. Bill's given us some good examples here. And let me give you a great example.
A great example is, I was a mayor's consultant on the 911 center, the planning and design of the Chicago 911 center. This was something that we built. This thing opened up in '95, and when it opened up, it had dual fiber optics to both central offices, plus it had 176 miles of dual fiber connecting 80 police and fire buildings throughout the city. Nothing like this was ever built before that, and the only other place that had as much fiber was a network carrier. So we really did a big job on this 911 center that is looked at as the #1 center in the United States by the Department of Homeland Security. So that's, if you're looking for an excellent example, look at that. Now you look at a bad example, look at Atlanta Airport, where they say, oh, we had resilient, we had all this dual things, but what happened was they had both power systems coming through the same conduit. So when that conduit caught on fire, that knocked out all the power to Atlanta. And my big question is, and I'll take 10 seconds, my big question is, how many other Atlantas do we have out there, whether it's commercial buildings or airports or whatever? How many other Atlantas are just sitting out there waiting for a disaster? You know, we have to make sure our designs are good.
Yep. And if you think about, I'm sure there's probably some people on the line today who were caught in Atlanta. I know I had friends down there. And I will tell you, there's a lot of people I know who now avoid connecting through Atlanta because it was a very painful few days. And obviously, as a commercial building, that's not a good advertisement. Well, I want to thank you both very much today. We are out of time. Thank you, Bill. Thank you for Jim. It's been great. We've packed a lot in here. There are some questions we didn't get to, but we will get back to all of you who had questions. I'll reach out to you on email, and we'd be happy to introduce you back to Bill and Jim as needed, and we can do some follow-up. Again, we will be sending out the slides. We were recording today's session. You will get an email in the next 24 hours with the details on how to get those. I want to thank you, Bill, and Corning for putting this together, Connected Real Estate Magazine for promoting it, and Jim for all the insights. So thank you, guys. It was great. Thank you.
Thank you.